Alright, so I saw this video asking if logic is normative. That is, if formal logic should be what reasoning is based upon, or what idealized reasoning should look like. And my immediate response was, what a stupid fucking question, because formal logic doesn't deepen work. So here's an outline of some of the basic fucking problems, right? So consider the truth table for a single input P and its implication Q, right? So P implies Q. Now if P is true, then we can assume that Q is also true, okay? So we get this line here. In is P, out is Q. True, true. However, if P is false, then we don't know anything about Q other than we cannot guarantee it is true. We don't know that it's false. We don't know that it's true. We don't know anything about it, right? That's what implication is. If P is our input and it implies Q, that doesn't in itself guarantee Q. And it doesn't guarantee that when P is false, not Q, right? So we don't actually know anything about Q in this case. If P is false, we don't know jack shit about Q, okay? Thus, when P is false, we necessarily get a Q value that is neither true nor false. Given this, let's consider modus ponens and modus tollens. Modus ponens. So, same exact truth table, because what we're dealing with is the implication. P implies Q. Okay? Since P implies Q, given P is true, unless you're completely fucking retarded, Q is also true. Think back how many times you've heard somebody say,
"Oh, by modus ponens, bleh."
Unless you're completely fucking stupid, of course modus ponens. Jesus fucking Christ, why is it even named? Anyway, this is where the fun occurs. Modus tollens. So, here, what we're doing is we are given that Q is false. Okay? Well, Q is our output, so it's not going to tell us anything anyway, because our input is P, not Q. Okay, so if our input is Q, well, we can't do anything with that. That doesn't tell us anything, right? Because that's why this is a question mark. This could be true, it could be false. Don't know. If it's true, it's still correlated to a false P, not necessarily a true P, right? Fuck. So this wouldn't tell us anything, okay? But also, there is no entry in our truth table for Q is F. So what the flying fuck? This is not an F, okay? Okay? We need to be using a trivalent logic in order to actually properly handle this. So, clearly the only thing keeping modus tollens appearing reasonable is the law of excluded middle. But it's also clear that at a bare minimum a trivalent logic is needed to properly handle modus tollens, which thus renders the law of excluded middle invalid from the outset. So let's consider the three laws of thought, of which law of excluded middle is one. Law of excluded middle. For any proposition, either it or its negation is true. So that's a formulation of the law of excluded middle. But notice that both 1 plus 1 is 2, and not 1 plus 1 is 2 are true, since 1 koi plus 1 koi is 2 koi, which gives us 1 plus 1 equals 2 being true. But 1 koi plus 1 gallon of water is not 2 of anything, thus not 1 plus 1 is 2 is also true. Fuck. Law of excluded middle is some bullshit. Law of non-contradiction, which is almost the same. Contradictory propositions cannot both be true at once. There is a subtle difference here between this and the law of excluded middle, but it's very small. Anyway, we can basically use our same example, but I'll change it a little just cuz. So, what's happening here is both 1 plus 1 is 2 and not 1 plus 1 is 2 are going to be true simultaneously, since 1 dog and 1 cat gives us 2 animals, but it also gives us 4 eyes. So 1 plus 1 is 2 and 1 plus 1 is 4 simultaneously. Look at that motherfucker. We've ruined both of these. Law of identity. Everything is identical with itself. Then why the fuck does modus ponens have a name? Because modus ponens, the way it's normally formulated, we say something like, if P implies Q, then if P, Q is implied. Look at this motherfucker. Look, if you just take out all the hemming and hawing, isn't that just the law of identity? What are you doing? Why do you have two things that are doing the same fucking thing? Why do you have modus ponens and law of identity? Why are you retarded? Anyway, there is a case where P is sufficient to guarantee Q. So here, not Q does in fact imply not P. And in this case, the expected behavior of modus tollens does occur. But in this case, P and Q must have very specific properties. Specific relative to each other, in fact. So they can't just be any random propositions. As such, the existence of this case really only makes things worse, because it's a fundamental dynamic in the way propositions operate, which has been completely dismissed for thousands of fucking years. You goddamn idiots. What are you doing? Jesus fucking Christ.